fix the values. So remember I was explaining like the standard form there. And then we explained that what you have at the end is the y-cut, what you have at the beginning is the shape of it. If it's smiling, if it's positive, your graph will smile. If it's negative, your graph will frown. So then I sort of use an example, y equals, if you like, you can call it f of x, but y equals x squared minus 6x. I meant to write positive 8. My apologies for that, instead of negative 8. So I butchered everything. So now, then I said that you're able to sort of sketch this graph. This is our way of trying to understand the standard form in detail. We're going to understand it by way of sketching the graphs, so, or the specific graph. So we have your graph. We already know that the y-cut is at positive 8. Positive 8, it will be somewhere there. So your graph would look something like this. We know it's smiling, so it looks something like this, where this will be positive 8. Okay? Or it could look something like something like this. Sorry. With this being positive 8, right? So maybe the graph would cross the y-cut or the y-axis on the left hand side, or on the left hand part of the graph, or could cross it or from the right hand part of the graph. Okay, that's how your graph would look like. So now, if they ask you to sketch this graph, it will either look like this or like that. So how do you know it looks like this or like that? By finding the x-intercepts, that is the points at which the graph crosses the x-axis, right? We've established that anywhere on top of the x-axis, anywhere on top of the x-axis, the y-coordinate is 0. The y-coordinate of this point is 0, the y-coordinate of that point is 0, the y-coordinate of that point is 0, anywhere on top of the x-axis. So we're going to take this to find the x-intercepts. There, we're going to take this original function, y equal to x squared minus 6x plus 8. We're going to replace the y with the 0. All right, and then we solve for x. All right, so you guys are free to write this function, or rather this equation, like so. As I said earlier, Ramaphosa equals Cyril. It's the same as Cyril equal to Ramaphosa, same thing. So that's what I did there. I just took this thing, put it there, I just put the 0, put it there. It's the same thing. So now this is just convenient, like, to deal with. So you could use the quadratic formula to find the x values, or you could use factorization, right? So I prefer factorization. Some of you prefer the quadratic formula. Let's just do the quadratic formula the standard way. Quadratic formula is minus b. You need to know it by heart. If you're able to memorize like a full song, the lyrics of a full song, that you're also able to memorize the quadratic function. That it's shorter than a full song. Sharp. So x equal to minus, what is our b? The b is the number in front of x. It's minus 6. Always put it in brackets, plus minus. What is our b? Minus 6. Always put it in brackets, because if you don't put brackets, you're going to get a different answer there. Okay? So as I said, minus 6 squared is minus 36, while minus 6 in brackets squared is 36. So always put it in brackets, minus 4. My a is the number in front of x squared. C is the number at the end. All over 2, my a is the number there. So this will give you answers minus 4, sorry, positive 4, and positive 2. Do you guys agree with me before I continue? So we continue. Those are our two roots. So now we know that the y, so the x coordinates of the intercepts are 2 and 4. So that's how your graph would look like. Sharp. Back to Umpo's initial question. Umpo asked us, sir, is it possible for us to find the coordinates of the turning point of a quadratic function if we do not have the the turning point form? She remembered, Gore, we are able to do so by just writing those coordinates down, by just looking at the the turning point form of a quadratic function. The opposite sign of p will be the x coordinate, the literal sign of q will be the y coordinate. So now that was a question. That was the base of a question. The answer is yes, you're able to find the x, or rather the coordinates of the turning point, using the standard form, but it's not like immediate. So how do we find it? From this expression. Here's the the formula for the x-coordinate of the turning point of a quadratic from the standard form. It is x equals minus b over 2a. So we substitute there. This is not in the formula sheet. What is our b? Our b is minus 6. Don't forget the sign. Our a, 1. This will give us an answer of 3. So this is the x-coordinate of the turning point. What about the y-coordinate? You just simply take the original x-coordinate and substitute it into the take the x-coordinate, substitute into the original expression for the function. So our expression is y equals x squared minus 6x plus 8. In place of, x, you put 3 in brackets always. This will give us 9 minus 18 plus 8, which is minus 10 there, minus 1. That'll be your answer. So therefore, the coordinates of the turning point of this function will be 3 and minus 1. And then makes a lot of sense. Look at this. It makes a lot of sense. 3 and minus 1 makes a lot of sense. This should be 3. This should be minus 1. So yeah, that's how you do it. You could also use like the the x-intercepts to find the x-coordinate of the turning point. I'm pretty sure that you guys have realized, Tori, the turning point of a quadratic, it's literally halfway through the x-coordinates. Like the distance from here to there is the same distance from there to there. So you could just find the midpoint of these two x values. You guys know the formula for midpoint goes something like this. Midpoint equals x1 plus x2 over 2, y1 plus y2 over 2. Then obviously just interested in getting like for the x, so just take this thing here. So x1 will be the 2 plus your x2 will be the 4 over 2, gives you 6 over 2, which is just 3. So this is another way for you to sort of find, the x-coordinate of the turning point if you've got the, the x-intercept, and then you can take this, substitute it into the original to get the y, y-coordinate. Delicious. Record. Sharp. So we were able to find the turning point using turning point form, and then the standard form using that formula. Standard form x equals minus b over 2a, and then whatever value we get there, we substitute into the original expression of the function, y equal to whatever. So now we are using the turning point form, the x-intercept form to find the coordinates of the turning point. We're going to use the same example. Proper. So I've got y equals x squared, the same example, x squared minus 6x minus 8, positive 8. Almost butchered it again. Now, you guys know how to factorize this, ne? You get that when you factorize that. You guys will then see that this is the x-intercept form of the quadratic for this specific quadratic. It's in this format, where your a is this value there is 1, then your x-intercept is the opposite sign of that, it is 2, and the second non-opposite sign of that, it is 4. Now, how do you find the coordinates of the turning point from the x-intercept form? There's only one way. You just expand it into that. In the exam, you're going to be given this, so you just have to expand it. How do you expand it? You're foiling, you're foiling. You just go x times x gives us how much? X squared. X times minus 4 gives us minus 4x. Minus 2 times x gives us minus 2x. Minus 2 times minus 4 gives us positive 8. X squared minus 6x plus 8 takes us back to, that's you haven't been given this in the exam and then you're asked to find the turning point. You do that, you just expand it, and after that it gets you to that point and just go x equals minus b over 2a. You follow the same procedure. We're all good.